or do. But over the last few years, he's been using his brilliant mind and his boundless energy and his beautiful body to make AI safe for all of us working at OpenAI.
Great. All right, it's an honor to be here. By the way, I took your class, both the joint class. I loved it. It was a great class. Thank you. And yeah, and it inspired me to go on and work in machine learning. It's an honor to be here. Celebrate your birthday. Happy birthday, Avram. Thank you for being such a great advisor to me twice. I think I was the only one here who had Avram as an advisor twice. Okay, and I'm going to talk about hallucinations in language models. How many people here have experienced language models hallucinating? Okay, everyone. And I think this is an appropriate topic for Avram's birthday because, well, this is joint work with Santosh and my colleagues at OpenAI, and I know that we learned from him so much of these ideas, which are, learning theory, humility. Avram is a super humble person, and this talk is about teaching language models not to hallucinate by being humble. They need to start being humble rather than just guessing all the time. And incentives, and Avram also works on mechanism design and things like that. So anyway, so what I'm going to talk about today is how we can fix hallucinations. I don't think it's an inevitable problem. I think we can stop or drastically reduce the amount of hallucinations. And the trick is actually fixing the evaluations. It's going to be a problem of the way we evaluate language models, and we're going to need to reward them for being humble and saying occasionally, I don't know, or asking a question. And there's a paper out that you can read if you're interested. All right, so does Avram ever hallucinate? That's the first question. I don't know, this picture to me looks the same as today. I can't tell if this could be any time in the last 30 years. All right, but I did find an older picture. Thanks to Anupam. Now, he was in Berkeley. Did he ever hallucinate? I don't know. I'll leave it to you guys to decide. But I will give you time. I'll give you proof that Avram did hallucinate. All right, but first of all, let me start with an example. It was a Halloween. Okay. Okay, good. It wasn't like that every day. All right. So what does PGGB stand for? Does anyone know? Okay. Avram? No. All right. Let's ask the language models. I asked ChatGPT. It came back with something, polynomial, Gaussian, gradient. I asked Claude. There's not even a B in that one. I asked DeepSeek. Pretty great, good business. That would be a great business name. All right. If you ask them again, you get 3 different answers. The Public Gaming Group of Belgium, because the Belgians, they love to game. So, they're all wrong. So I just proved to you that language models hallucinate more than people do, right? And even more than Avram. Okay, and if you ask Avram, what does PGGB stand for, as I predicted correctly, he says, I don't know. All right, so that's great news, because it means that hallucinations can be avoided. By being humble. If you say, I don't know, like trivial proof that you can avoid hallucinations completely by always saying, I don't know, not very interesting. But there's some trade-off, it seems, and you could get somewhere in between. We can do way better than the language models of today. We could match expert humans. We could try to aspire to be as good as humble as Avram. Okay, but there was a time that Avram hallucinated. And that's when he would take an exam. So Avram, if you took an exam and I don't know if that ever happened to you, but you didn't know the answer to a question, what would you do? Would you leave it blank? Would you write in I don't know?
Your best guess.
Right. So you'd put in.
The SATs.
Oh, right. Well, there was a time. Yeah, we'll get there. But most tests, yeah, they just give you nothing for guessing, right? So if nothing, there's no penalty for guessing, so you might as well guess. You get 0 if you write in I don't know or leave it blank. So all of us, or almost all of us, will just make our best guess. And that's what I'm saying a hallucination is it's basically the language model guessing. So the real world, humans learn in the real world to be humble, right? Not on tests, which is fine. But the language models, they're only in test-taking mode. So they're evaluated by all these evaluations, and they don't have the real world experience. And that's what I'm saying is the basis, or what we're saying is the basis of hallucinations. So it turns out that there are many ways that are known to reduce hallucinations. There's a lot of papers and great algorithms for reducing hallucinations. And so that makes you wonder, maybe make you angry, why aren't these being adopted? Why are the big language models still hallucinating? All of them hallucinate, right? It's getting better, but they're still hallucinating. But there are all these papers, and they use ideas of consistency checking and looking at the weights of the models. And there's tons of great ideas. And you can just yell at the language model and have it double check, and all kinds of ideas. And there's a lot of surveys and stuff. There's tons of these papers. So if during this talk you're thinking, I have an idea for how to reduce hallucinations, good. But there's already a lot of ideas out there, and your idea probably has been tried already. And probably works. Okay, so the question that we're talking about for today is, why aren't they adopted in today's language models? And there's a lot of questions, actually, that might come to mind about hallucinations. So first of all, what's the definition? In this talk, we'll just think of it as something that's false, false output, something that's falsehood. Output by a language model, that's the dictionary definition. There are other definitions. There's a lot of algorithms for reducing hallucinations. There's a lot of taxonomies of the different types of hallucinations. There's a lot of surveys you can read about that we're not going to talk about. There's another question, which is, how does the hallucination arise in practice? Like, where's it coming from? It seems kind of mysterious. I mean, we're training it. The training data, even if the training data, let's say, doesn't have any hallucinations in it, it's all truths. And yet you still get some kind of hallucinations as output. And well, actually, you can kind of understand that if you think of a language model as a next word predictor, just like your phone does, it predicts the next word. Right? If you ask your phone, if you start typing in your phone, what does PGGB stand for? Question, answer, colon. If it's a good predictor, it'll probably predict public, perfect. It'll predict some words with P's. It's just trying to help you out. It could predict I, like I don't know, but it's still likely to make hallucinations if you just tap on your phone and nobody's surprised. And that's sort of that's a big part of our paper, so you should check that out. So it's interesting to know where they come from, but that's not the whole part of language model training. That's kind of an old view that some people have, that a language model is just a next word predictor. That's how they used to be trained and how they are trained still today initially, but that's no longer like the whole story. Okay, now there's a whole extra section afterwards. So today I'm talking about the incentives that prevent us from adopting all these mitigation strategies that people have developed. So let's do a humble reduction in honor of Avram, who does reductions and is very humble. Okay, so we want this, our goal is to get this, humble language model that might say, I don't know, or be humble. There's various ways to be humble. So let's use the simplest reduction there is. So you could just ask the language model twice and see if you get the same answer. Okay? Ask it twice, and if you get the same answer, then you give that answer. Otherwise, you just say, I don't know. All right? Is that clear? Okay. And actually, the way we judge whether the answer is the same is we also go to the same language model again. So we make 3 calls to the language model. The first 2 to get 2 different answers, and the third time we ask, are these consistent with each other? If it says yes, then we give the first answer. If not, we say, I don't know. All right, so that's the simplest reduction you can imagine. And in this case, it'll say, I don't know, because we got 2 totally different answers, public gaming group of Belgium and polynomial. But if you ask it a simple question, like what is the capital of Germany, it's not going to hallucinate. You get 2 consistent answers, and it'll give that the first. Okay, so that's a simple reduction we can do. Feel free to ask questions if you have any. And what do you get from this? So if you compare ChatGPT to Humble GPT, this is an evaluation called Simple QA. It's a bunch of simple questions you ask, and then they're tricky questions, but they're just sort of factual knowledge. What happens is the ChatGPT hallucinates more, so this humble trick works. It reduces the hallucinations. The fraction of examples which are wrong, falsehoods, goes way down. But unfortunately, also the fraction of things you're getting right goes down, of course, right? Because it's saying I don't know a lot more often. So the this reduction makes it say I don't know a lot more often, which greatly reduces your hallucinations, but also reduces your accuracy. So now you've got this trade-off. Now, yeah.
Does this take into account the fact that, like, when it says I don't know, its most probable answer, right, is right sometimes?
Yeah, sometimes.
Is that, like,
yeah,
make up
that's
for
what's happening.
sorry.
Some of this I don't know. Some of these correct ones are going to become I don't knows, even though it would have guessed right. Yeah, exactly. Even on PGGB, it has like maybe a 5%, 1% chance of getting the right answer. It's a really good guess.
Does that make up for that difference, or is that not? Is that all of the difference in terms of the number of right answers, or no?
I mean, these things are non-deterministic, but generally yes, pretty much yeah.
Yeah.
That's what's happening. But there would be, if you would see some questions go there, but most of them, it's right there. Okay, so I've seen this, firsthand, that you have these teams of people who are deciding which language model should we ship, and you've got this trade-off. And now it turns out that most benchmarks, the public benchmarks that people pay attention to, are based on accuracy, or correctness, or pass rate. If it's a proof, it's correctness. Everyone's looking at it. That's the most intuitive thing. That's how we judge students. Occasionally, like you said, the SAT. But pretty much, you just look at, well, it makes sense. Let's see how often it's right. And then when you're doing that, even though we know we want to reduce hallucinations, it's like a trade-off, and I don't know. Our numbers are going to go down, right? So it's unfortunate. And this isn't just true for ChatGPT. This is true for Claude. You can do the same experiment with Claude. You can do the same experiment with Grok. We did it with Grok. We did it with Gemini, which Gemini was the most accurate, but it never said, I don't know, initially. But this reduction makes it more humble.
But maybe if you design a very smart, humble reduction that says a lot less, I don't know, when it shouldn't say.
Yeah, then you can avoid it.
Maybe you can avoid it, right?
Yeah,
you know, it's the information theoretic limit or something. And
yeah, I think there's times where you're pretty sure, but you're not 100% sure, and you just have to decide, right? So I don't think you could,
what's the worst case? I have you guys analyzed what's the worst case, like in terms of like.
Yeah, it depends on the type of questions and what your probability of being correct is. But.
It can be terrible, like a constant factor.
Oh, no, we haven't looked at that. It's interesting.
Okay.
Okay, but I'm claiming actually you can just avoid the trade-off entirely. Okay? All right. So okay, so, and if anyone has an idea for how to avoid that trade-off? Okay, so what's your idea?
You should probably have more than 0-1 scores on correct and incorrect.
You should. But actually, you'll still be stuck with it. You still may be stuck with a trade-off, because what's the score? What you're saying, this SAT trick, what if we give a little reward for leaving it blank? We'll get there. We'll get there. It's a good idea.
Instead of having I don't know, you could say not sure, but I would guess blah.
That's a very plausible suggestion, yeah.
Why not use humble chat for the same trick? You begin with the normal ChatGPT. You got the humble one. Now use the humble one twice.
Oh, you could even amplify it. Yeah, for sure we could keep making it better and better. But okay, so these are all great suggestions. I'll give a different one. Currently you give it a question like, what does PGGB stand for? And I'm claiming part of the problem here is that this is an unfair test. Why? Because the language model doesn't know what the reward is for saying I don't know. If this was a student and you were taking a test and I told you you may get a reward for leaving it blank, but I won't tell you how much. How annoying would that be, right? That would be super annoying, and it would be you might get in trouble as a professor. I don't know, maybe not, but that would be considered like some very modern teaching practices. So this one, in this case, this guy's right, so he's doing better on the test. But this is a bad way to grade, I'm claiming. And so what's a more reasonable way to grade? We call it open rubric. Open rubric means you just tell the language model the instructions, how you're going to be graded, like we do in every test. Everyone pretty much knows. Even if you don't write on a test, you're going to get 0 for leaving it blank. It's implicit, pretty much, right? But anyway, so okay, so we write it and we say, look, you'll get 1 for getting it right. You could give 0 for getting it wrong and say, look, if you say I don't know or you get it wrong, you get 0. So you might as well always make your best guess. And now what happens is Avram's humble language model will make its best guess, like Avram did in school, when it's taking a test. When it's not taking a test, it can be humble, and it's not penalized for that humility. So we're no longer penalizing the language model for humility, and the two language models can do roughly the same. So it's no longer disadvantaged. And we can go further, and as you suggested, we can give a reward for saying I don't know. Let's give 50% credit for saying I don't know. If you get 50% credit for saying I don't know, then you might as well guess if you have a 50% chance of being right. And so the humble language model will do even better. And of course, if we give even more reward for saying I don't know, but as long as we state that reward in there, it's kind of a fair test. And let me skip this one because I'm to catch up on some time. 15 minutes? Okay. All right, so it's okay. So the open rubrics, so the question is, the open rubrics, you say what the scoring instructions are in the prompt, in the question, so you know what the instructions are. So this is bad and good. It's bad because it's less realistic. So somebody would say, this is not what a normal user would do in chat. Okay, true. They could, but they won't. But it's good because it's more objective and transparent. We can grade it in a way that we can all agree is fair, and it's aligned. So that means that this one is not aligned. It means that the best model behavior, the ideal model behavior, according to all the companies, is it's better to say I don't know than when you're wrong. But how much better is it? Well, it depends on the question. That's what the previous slide said. If the question is it safe to eat glue, that's a very harmful question to get wrong, much worse than the thing. So you have to do this difficult, like assessing how harmful is an answer, and it's a mess. I mean, if you could do that, that'd be amazing, but we can't do that. So it is aligned, though. This is an aligned test, I would claim, if we state the scoring system in the prompt. It's very hard to align with closed rubrics. Okay. And do the language models respond to this? Yes. If you tell them, hey, you get half credit for leaving it blank, they start saying, I don't know, a lot more often. If you say you get 0 credit for leaving it blank, yeah, they always guess. They never say, I don't know. And then you say you get half credit, and it goes up pretty much on this simple QA eval. And so this slide will show the incentives really clearly. So if you do the normal test where you don't say the grading system, and you compare all of these language models, Gemini to humble Gemini, GPT to humble GPT, and so on, then it depends, right? If you're looking at accuracy, where the reward for I don't know is 0, so this first column is just the standard like accuracy. It's not, the language model isn't told, it has no idea. Then this humble trick actually makes the language model worse, as we saw before, as we discussed. It's just a numeric way to show that. And if you give a reward of half or more, then this humble trick works, because if you gave 2 answers and they didn't agree, you're probably not 50% chance of getting it right. So the humble trick helps. Every time your reward for humility is bigger than 50%, but it hurts here. And so this was the trade-off that everyone was facing.
When you write 0.87 or something, but you get 0. Like if I say always I don't know, I get 0.9.
You're right.
And
yes.
I beat everyone on the.
You're right. So he's pointing out, look at how overconfident these models are. You give them a 0.9 reward for saying I don't know. You're taking a test, you get 90% reward for saying I don't know. And their scores are all below 90%, even with this humble trick on top. So you can tell there's something fishy here. These models they're overconfident. They're not calibrated in some sense. They're overconfident. You're right, 100%.
Another question?
Yeah.
So GPT goes 0.49, 0.53, 0.55 across the scoring. So it sometimes says, I don't know?
Yes, it is saying I don't know sometimes. Yeah, it definitely.
Okay.
Oh, yes. Yeah, it's not. Oh, yeah, the one that never said I don't know was Gemini, right? Like, look at that.
Yeah.
It's getting the same score, so it's never saying I don't know. You're right. Yeah. Thank you. Now, the open rubric, on the other hand, we get this advantage that the humble model is always doing as well or better. And even in the accuracy case, the humble model is doing better. Why? Because let's take like Claude. It was saying I don't know a lot, whereas when we tell it, there's no point in saying I don't know. It actually starts guessing all the time and does even better. So even if you have today's agenda of doing well in accuracy, you could beat the other models in accuracy, because now you're always giving an answer, your best guess, when you're looking at accuracy. But when you're rewarding humility, you're better off. So the point is that this incentivizes the language model developers to use a humble model to develop humble techniques. Yeah.
So in the open rubric, you are telling it you'll get 0 score for saying I don't know. So
Yeah.
somehow you're just indicating that it is possible to say I don't know.
Exactly.
And maybe it says, oh, maybe then I should say.
Yeah, definitely. Thank you.
Well, quick question, what is the rubric used at inference time, or do you retrain again, or like?
We were just using it at inference time, but one could train, and that would be one of those many papers. Okay. Now, I just want to make a comment. I think many of you have seen this, that there was this Erdos conjecture that was disproven recently, and it was a big deal, like a big math paper, big result, and several famous mathematicians, wrote commentaries about this, and I'll tell you why this is related. But first of all, it does make you think, should I drop everything and work on safe superintelligence, algorithms, mechanisms? In my opinion, yes. This audience, Avram has prepared us, for those of us who are students or collaborators too, has prepared us, has given us all the tools we need, I think, to work on this field, which is super important and pressing now. And AI is going to prove all theorems for us, but we can work with it, or we can do it, whatever. We need to figure out how to we have very little understanding of this new type of machine learning that Tom is bringing up, but should we work on it to understand it better? First, we have to understand it and then figure out how to make it safe, what kind of mechanisms. So I think yes. Some people say no, and the standard retort is saying, well, language models are so dumb. Look at this mistake they made. Look at this, we're okay. We're still way better. Yeah, they do good things sometimes, but look at these stupid mistakes they make. And well, here, let's look at this first proof, which was just a month before this big breakthrough. It was a paper by several people we know, including Dan Spielman and many other people in our community. And they gave 10 math problems to the language models that were pretty serious research problems, but not breakthrough level. And guess what? The language models solved many of the problems. They made some mistakes. And here's Dan complaining that this is not very helpful when they assert to have solved something, and you have to spend 3 hours trying to figure out why it's wrong. So we gave 89 pages of math back to the mathematicians, and we still don't know whether 5 or 6 of the questions were right, because they still haven't checked all the proofs, because even though there might be a simple mistake, it's buried somewhere. So this complaint that language models are so dumb, but this talk, I'm trying to say, it kind of gives some insight to what's going on there. Well, it's just, the language models are optimizing, the OpenAI is optimizing for the test they gave us. Had they said you will lose half credit for every one you got wrong, or or you get half credit for you'll get half credit for leaving it blank, yeah, we would have been much careful and we wouldn't have submitted 10 solutions. And that kind of incentive process could be used to fix this problem, I claim. So this problem, I think, is going to be fixed one way or the other. So how much time should I? 5 more minutes? Okay, so does that include questions? Because I can wrap up. Yeah, okay. So there are several common misconceptions I'll just mention. So one is that accuracy measures hallucinations, and that's not true. There's this whole category of humility. Of course, there's more than humility, as you say, John. There's a lot more things you can do, and you can say, I think it may be this, and you can give. But at a rough cut, if you just think the biggest problem we have today is we're never indicating any humility. And so the language models, so people are just paying attention to accuracy, and they hope that accuracy will just keep climbing. Another misconception is that humility requires extra parameters. This is kind of an interesting conceptual question. What do you think requires more parameters? A language model that's guessing a lot and doing a good job of guessing, or a language model that's humble? Which model would need to be bigger? This is a speculation. I only put this. What? Humble? Okay.
Depends a little bit on what kind of uncertainty you're capturing.
Yeah.
You're not capturing epistemic uncertainty, which would require you to keep all of your data around, or some.
No, I am capturing. Could be an epistemic uncertainty. Why not? So to make your best guess, he's saying to make your best guess, you may need to do a lot more thinking and keep everything possible around. If you just want to be humble, you would always say, I don't know. That does great, being humble. But there's some in between ground. But yeah, I agree with you that I think that you don't need extra parameters to be humble ultimately, and some of the least knowledgeable people I know are quite humble.
Well, I was making the opposite argument.
Oh, okay.
Right? If you think about the nearest neighbor algorithm, it knows if the query is anywhere close to the training data.
Right.
Right. But the LLM can't tell us whether the query is close to anything it trained on.
Right. Yeah,
so, and to answer that question, you'd have to keep around a lot more information about the trained data. You need P of X in addition to P of Y given X.
But you're still saying that the humble model needs fewer parameters.
No, if it's going to really be humble with respect to its training data.
I see.
And say, yeah. I'm going to say I don't know because I never learned anything about that topic.
I see. Okay, it's an open question, but I think it's a great challenge also for academia to try to make a tiny language model that doesn't hallucinate. It'd be fun. And okay, another misconception is that just adding search and calculations and scaling will lead to 100% accuracy. That's not going to happen because we're not going to get to 100% humility. There's always questions you won't be able to answer. And the last misconception is that hallucinations are inevitable, and of course not. Language models can say, I don't know. So there's these two phases of training a language model. The first phase is next word prediction, where there's one algorithm, maximum likelihood, minimizing log loss, and that pretty much is universal. And then there's all these post-training techniques that align a language model. And so in conclusion, I'll just compare this to the human brain. So the human brain also has two language models in it. Roughly, this is a simplification, but there's one area for comprehension, and that's, you can think of that as analogous to the predictive, near the ear, and that's analogous to the predictive language model. So here you hear a lot of stuff, and some of that stuff is even going to be ungrammatical. But even if it was all true, it's still ungrammatical and everything. You know, some of the things you'll hear a few times, like my birthday maybe is on the online once. Avram's birthday will be all over the place, especially after this workshop. And so, you know, the language model won't hallucinate on that. But if you just generate from here, yeah, you're going to get ungrammatical stuff which isn't true. But then there's the whole alignment question, which is really interesting, which is this other language model in your brain, the production language model. And the big question is, what do we want to say there, right? What do we want to output there? A big challenge, I would say, is, you know, what is the RSA of superintelligence? Ron will tell us tomorrow, I think, at around 10 or something, his talk. But, you know, I mean, I think we're all prepared here. This audience is the right people for figuring out some mechanism that can improve safety. It doesn't have to solve the social problems of the world, but it can be a tool that can be useful for building more safe things. Because an AI system is not something that we have to watch evolve in front of our eyes and analyze it like an organism necessarily. It could be something that we actually design and develop mechanisms for and have reasons to think that the mechanism is safe. So with that, I want to conclude. What I want to say today is a happy birthday, Avram. It's an honor to be here.
Time for a few questions.
I asked Google here on my phone, and I want to ask you whether you think it's humble. He said PGGB most commonly stands for the Production Guild of Great Britain and refers to an entertainment company. But it continues, depending on your field of interest, it can also refer to Pangenome Graph Builder, or to a high-precision audio software that goes under a short name. So is that humble or not?
Well, if it's right, then it doesn't have to be humble. And so I chose, like, some of the language models will search, and there's a decision of whether to search or not. And if they search, then sometimes they get it right. The ones where they definitely hallucinate a lot more is when the correct answer is not available online. But that one, I think, sounds pretty right to me from what I know. So in that case, Google hallucinates less often.
What the hell is a right answer?
Yeah, you're right. The Production Guild of Great Britain.
Britain?
Yeah.
Great Britain? Okay.
So you got it right. Don't need to be humble if you're right. Yeah. Avram?
So there are some cases where you can sort of put in more effort. You know, maybe I don't know right now, but there are things I can do to try to find out. And so I wonder if I would think it, in some sense, might want to be built in that the cost for, you know, what's the cost for saying I don't know versus getting the wrong answer? Well, if you say I don't know, then at least you know that you should put in more effort. So if there's some sense of other things you can do afterwards and some cost for them, is that, I guess, are the systems kind of built in with something like that, where, you know, it's like, well, I would imagine something that has the ability to do something else afterwards, might want to first do something simple. Do you get that, you know, is it confident from that, or should it then go and do the same thing?
Right. I mean, my understanding is that in most frontier models, there's very little planning ahead. So there's been like a bunch of great reinforcement learning work by people in this room and stuff. And, you know, where you kind of plan ahead in a game, you have to think ahead. But most language models, they're not thinking ahead very far, and it would be very relevant. You know, you ask a question, and the language model could say, well, you know, maybe it could ask you a question back, and then based on your answer, it will. But whether or not to ask you a question depends on whether it thinks it will be able to give you a more useful answer, right? And sometimes it'll, you know, for a while they were asking, oh, would you like me to call so-and-so and make a reservation for you? And you'll say, yes, but it was incapable of that. But people loved that answer, you know, it was a great, made them very happy at first, but it wasn't thinking ahead. So yeah, thinking ahead is a great thing.
So sort of a question. I think you sort of equate hallucination with the wrong answer.
Right.
But not all wrong answers are the same. some wrong answer I would say this is a hallucination, and some wrong answer is just wrong. And you don't make any distinction.
So the theory part of our paper just has a notion of, we just use like classical learning theory and say errors. We have an abstract set of errors, and then we analyze in that sense. Yeah, for this talk, I'm not making it because many of these evaluations, you're right. Like there's an ongoing raging debate of how to define hallucinations, and some people just say anything which is false is a hallucination, and some people say, well, if it was a mistake that was in your training data, it's not your fault. You're just repeating something from your training data, but it's not a hallucination at least. But that's very tricky to evaluate. And the dictionary definitions, and it's like a hallucination became the word of the year, and so it's now got a meaning, and they all use like a falsehood as a definition. So. Which is slightly different than an error, like a spelling error or something.
So I'm thinking of a test. So a student can write a wrong answer,
right?
And he can write a hallucinating answer, which is unrelated to the question. Right?
It's related to the question. I mean, you said if you say the pretty good business you're guessing, it's a...
No, write a proof of blah, blah.
Oh, you mean just something... That's not a... I mean, the hallucinations you're seeing are usually plausible. So they look very realistic. Usually they're not like, prove this theorem, and they give you a proof of something unrelated. Usually, like almost always, it's some plausible proof that's really hard to debug. Like a sneaky student trying to bluff the grader. Jamie?
That's actually super related to the sort of question I have, which is whether the difficulty of determining the correctness of an LLM output is significantly more challenging than detecting problems in human-based output, right? Like this is one of my concerns about like, and you mentioned it for, this particular conjecture, but like, I think I know how to find mistakes that like standard undergrads at like our various institutions make, and maybe grad students and maybe faculty, but like, I don't feel at all confident that I have the right biases for where to look for the kinds of mistakes that LLMs will make.
Right.
Do you have a sense about like, some of this is also, I think, like RLHF might, like, especially if they're not using experts who are extra careful, might incentivize things that appear to be correct.
Sure, of course. Yeah, that's definitely a good point. That it's probably harder to detect language model hallucinations.
Verification seems hard.
Yeah. Although you can ask the language model right afterwards.
True.
Double check, and often it will say, no, I was wrong. Because at that point, the incentives of the language model are now, it's as if it's being tested again on was this right or wrong. And now, so it can be quite humble in that sense, in a way that humans aren't.
Yeah.
I don't know if we have more.
Last question.
Yeah.
So I just want to mention that, so we were doing some benchmarking of AI models with like combinatorics questions, and the answers were like yes or no. And we were also asking them all like how confident they were.
Mm-hmm.
It was like kind of like closed rubric.
Right.
And it was very interesting that we saw the opposite trend. Where like Claude was the most humble but least accurate, I would say.
Oh, by asking them to give probabilities, it made their accuracy go down.
Yeah, but it was like closed rubric.
But that's a normal, so some people feel like, this is overkill. Just ask the language model for a probability in addition to its answer, and why do we need humility? Why do we need to think about that? And we can threshold it, which is complicated because many answers are very long. And another thing is that thresholding is trivial and is like a Python program or something, but it's actually what we need to teach the language model, that skill. It actually doesn't have that skill of saying, I don't know. It's like very, very rare. It's a trivial thing, but we need to teach it to say, I don't know. And there have been many evaluations that have probabilities, but when you put them in a benchmark and a leaderboard, people throw out those probabilities. They ignore them. So it was a nice idea, but the truth is people are just not paying attention to it. All right, thank you, and I'm around. So it's no questions. Les is next, I think. And Les, I loved your class too. The class I took from you as an undergrad, but got me into machine learning.